use of an auxiliary line. So if you take a look at what this lesson is going to include, is it's going to include a diagram like we've been seeing, some parallel lines, and notice that they're now not cut by a transversal. They're including two segments. So they kind of stop before they reach the other transversal. So what this lesson is going to focus on is using an auxiliary line. So an auxiliary line is just an additional line that we're going to be drawing into our diagram. Okay, so you'll hear us use the term auxiliary line, and that means we're going to place an additional line somewhere in our diagram. Typically, the lines that we use when they're auxiliary lines are parallel, or we extend lines. So we're going to, up here, try to use an auxiliary line to find the measure of angle W. Okay, so let's take a look. So the first way that we're going to do this, and then we're going to show you how we would, is auxiliary lines are great when you draw them parallel to the two given lines. So it's pretty clear that my given lines that are parallel are here and here, right? Because I have my my little arrows to show that. So here are my parallel lines. Now if I wanted to draw an auxiliary line, I'm going to make it dotted. Arrows on both sides to be nice and proper. Okay, so now my auxiliary line, I want to draw it so that it helps me in some way, right? An auxiliary line, you can think of like auxiliary police, they help, they're like helping police. All right, so it wouldn't be helpful if I put it here. I wouldn't find any measures, not here, not here, not here. But if I put it right here, and now you take a look at what I have. It looks like angle W is just split into two parts. Not that they're equal, but it's just split. And now if I actually take this screen and I hide right here, now I have these parallel lines in blue cut by this little transversal here. Now remember, transversals can stop or go through. And what begins to kind of arise is we have all of those now relationships: alternate interior, alternate exterior, so on and so forth. So if I take a look, I actually know right now that this little angle right here at W has to be 41 degrees because it's the alternate interior angle to this angle here, right? So now these two angles are alternate interior angles. Make this a little bit smaller. Okay, so now that means that this angle over here should also be 41 degrees. There we go. Okay, so alternate interior angles. Now, we have another side. We also have the side over here. So if you kind of take a look, and again, if I hide it, or even if you take your hand and you place it over this piece here, and then we take a look, well, what do we have? Here's one parallel line. Here's the other. Here's our transversal. These are alternate interior angles again, here and here. So if this is 35, this angle here must also be 35. Okay. Now, by doing that, what I now have are two measures at W. I have 41 and 35. So W is the sum of both of those angle measures. So I would find the measure of angle W by adding 41 and 35. So measure of angle W equals 76. Okay, and there we have that. So that's one way. And it just so happens to be that both of these relationships are alternate interior angles with this diagram. Not always the case, but this is the specific case here. All right, So let's take a look, same diagram. Let's try to use it another way. So what's another way we can use an auxiliary line? So besides drawing in a line parallel, we're going to extend a given line. So we're really given 1, 2, 3, 4 segments here. So they're saying extend them. So perhaps I see this as my transversal right here, and I want to extend it down and through. Right. And I always suggest one at a time. I'm going to put this over here. You don't want to go crazy and drawing all these lines everywhere and make yourself all, nuts. So one at a time, extend your lines. Okay. So now once I did that, I take a look. And again, I'm big into highlighting. So here are my parallel lines. Okay. Here's my transversal. That means that these are my alternate interior angles. So I have alternate interior angles. And I'm going to just mark them here and here. Okay, so now that means that this angle in here, these are alternate interior angles. So again, maybe I'll just kind of show you that by putting little arrows here and here. Right, we have alternate interior angles. Okay, that means that they're equal. Perfect. So now since I have my alternate interior angles, I can say that this angle is 35. So I'm going to put that right in here. Perfect. All right, so now I have my 35, my 41. I need to get to W. So now I kind of take a look away from the parallel lines. And what can I do? Well, if I do that, I notice that I see a triangle, right? And my triangle is right here. I'm going to highlight that in blue. So in a triangle, the three angles must sum to 180. So I'm going to put angles in a triangle sum to 180. That means I have the 41 and the 35, which is 76. Right? And then I take that away from 180. And I get 104. Okay, so now I have here this angle, the remaining angle of my triangle is 104. Okay, and my last step that I see, I'm going to kind of take a look here, is W and 104 are adjacent on a straight line. So these two angles make up a linear pair. Right, so these two angles are on this straight line. They have to sum to 180. So over here underneath, I'm going to put linear pair, right, sum 180. So that's W plus 104 equals 180. Oh, so that means that W equals 76. And that's what we found before. So 76. And that's how we can again come up with 76 as your final answer, just like we did while putting in the auxiliary line through. Now definitely this way is a little bit more in terms of you have to do alternate interior angles, angles in a triangle, and a linear pair. But maybe that's how you see it, right? It's completely up to you. Okay. You could also have extended the other line and done it the other way. I don't know if I have another. Yeah, just to show you quickly, very similar to what we just did, we also could have extended this line here, like this. Just move this all over. Could have extended the line, and then you could have done your alternate interior angles here and here, and then again found the vertex, and then done with the linear pair here. Okay, so there's a number of different ways you could go ahead and work through to find that missing angle W by using an auxiliary line. So a couple of notes that we would like you to take on this is when or how you manipulate your diagram is first you draw in your auxiliary line. Somehow in a diagram where you don't have that transversal cutting through, the auxiliary line can be drawn a number of different ways, right? You can kind of draw it through the vertex of the angle right here. You can go ahead and extend the transversals or extend them to go through as so, like this. Sometimes it's helpful to actually extend even the parallel lines, right, and make them go through so you can kind of see a little bit more clearly. That's what the extend lines mean. And then also like removing extra information. So if you're looking at this and you're like, oh, this is too much, just too much, maybe you take it up and you cover up a piece like this and ask yourself, what do you see? So on and so forth. All right, so what we're going to do next is we're going to look at these two diagrams and we're going to decide, is an auxiliary line necessary for both diagrams? So if you take a look here, you can pause this and I would like you to take a guess out or try it out. Do you think we would need an auxiliary line for both? And I'm going to go ahead and go through it. So if I take a look, an auxiliary line, so the answer here is no. It's not necessary for both, right? It's necessary here, and it's not necessary here. And let's take a look as to see why. Okay, so maybe let's go with where we don't need the auxiliary line. So we don't need an auxiliary line here, and the reason being as to why we don't is because I have my parallel lines here and here, and I have my transversal right here. So right off the bat, these are my alternate interior angles here and here. So though it's a complicated diagram, it boils down to I have parallel lines cut by a transversal, so the auxiliary line is not needed. Now over here, if I need to figure out the measure of angle R, first step is definitely going to be to somehow maybe extend some lines. I'm going to extend this line. I need to find R. So maybe I even go as far as possibly, extending this up here to create this transversal and go like this. And then once I do that, I can take a look at my parallel lines now, here and here, and this transversal. And if 130 is here, its alternate interior angle is here. So I have 130 here. Okay. But again, I wouldn't have been able to even do that if I didn't have this auxiliary line. And now I take a look and I have this angle and this angle are a linear pair. So I can do 180 minus 130. And I get 50. So now I know that this angle, just put a little arrow so we know where we got this from. This angle right here is now going to be 50 because that's our linear pair. Okay, and then I actually have another linear pair here and here. I have to get to R, so I need to figure out this angle right here next to the 96. So again, it's going to be another 180 minus 96, which gives us 84. Okay, so I can fill in 84. And now I just have that these three angles, the 50, right, the 84, and R are angles in a triangle. I take a look, and here's my triangle. So a triangle must sum to 180 degrees. And if that's the case, I'm going to do 50 plus 84. And that gives me 134. And then I do 180 minus 134, right? And that gives me 46. So I know now that this angle has to be 46. There it goes. But I would have never been able to do this if I didn't add in this auxiliary line right here. Okay, so here's your two examples. Okay, so what we now have are two practice problems, 1 and 2. So I'd like you to pause this, take a couple of minutes, try them out, and then you can kind of come back, hit play, and listen to me go through the results. Okay, so for number 1, what I would do here, again, there's a number of different ways, but the most direct, without kind of getting yourself all crazy, is to just extend this line here, okay? And then I can maybe even if you really like to, extend this line here, okay? And then I'd like to just, let me see if I can move this all over. Perfect. I'm going to start with now saying, I'm going to look here and I'm going to say, oh, look, I have some alternate interior angles. My alternate interior angles are right here and right here, right? So then this should be 35. Okay, so maybe I'm going to even just point out alternate interior angles. Okay, so my alternate interior angles are equal, so that's how I was able to figure that out. And now I take a look and I see that I have a straight line right here, right? So that means that these two are my linear pair, so they have to sum to 180. So I now know that I have a linear pair, so that means they sum to 180, and that's D plus 35 equals 180. So if you subtract 35 from both sides, you get that D is 145. So this right here is 145. Okay, and that's how we then got D there. Okay, so not bad. So parallel lines cut by transversal, we have our alternate interior angles, and then we have our linear pair. And now the next one is a question that says, Dan finds the measure of angle G to be 85 degrees. Is he correct? Explain why or why not. So I don't know if yours has this auxiliary line drawn in, but mine does. And I'm actually going to add some additional auxiliary lines. Might just be helpful to put this one here and this one here. And then I'm gonna think, okay, so what can I now fill in? So I'm gonna take a look and I see that this is 125. So you know what I actually noticed? I see that here, so this angle here and this angle here, this tiny angle, are same side interior. So they have to sum to 180. Right? So that means I have to do 180 minus 125, and that gives me 55. So this tiny angle up here at G is going to be 55. And make this nice and neat. Just give me 1 second. This little angle here. Okay, so now this is 55. Blue, great. And I have the same relationship down here, right? The 155 in this little part of G. So again, I'm going to just point that out so we all know what we're talking about here. Okay, so then we have we have 180 minus 155, right? So then that's going to give us our 25. Okay, so now angle G. So the measure of angle G is equal to 55 plus 25, which is 80. So is Dan correct? No. The measure of G is 80 degrees. Same side interior angles sum to 180. And there we go, right? We have a little explanation there. We're saying we know the measure of angle G is 80 degrees because we use same side interior angles and they must sum to 180, right? And therefore we have here, and then we showed our work up here. So that would be this, a good response. Okay. So that finishes up auxiliary lines. Remember, you can use an auxiliary line to extend a line, draw in a line. You want to work to always cover up extra information, possibly turn your paper, all things like that. If you have any questions, please reach out to us through email or the Google Classroom.